All right, we're recording. So with that from last week, we talked about, well, let's just start from the beginning. Last week we talked about, where the heck is the draw? Classes. And so, oh shoot, before we do that, where the heck? We are in, please be this correct one. All right, crud. I cannot remember what we called this. I have too many of these projects already. It's the worst. Project polymorphism. Here we go. So we talked about, so in our main, we're talking about polymorphism, and we'll get to that eventually. But ultimately, we were talking about, having multiple classes. Each one of those classes, so we have a car, an airplane. Actually, I don't have to draw these, I can just do this. We have a car, an airplane, a bicycle, and a truck. We also had a combustion powered thing, and then we had a vehicle. You're probably wondering why. If you weren't here last week, bear with me while I draw this ridiculous things. So let's put some text on here to this up. So vehicle, it's pink, nice. Crud, mouse. I think this is easier to read. There we go. So text, there we go. So text. Combustion powered thing. Move that up a little bit, makes more sense. Then car, airplane, truck, and bicycle. Okay, cool. So what we had, so if we look inside of each of these, so airplane has, wing type and radar and cargo hold capacity. I'm just gonna wing, radar, cargo. What does car have, or bicycle? It's like a bicycle. Bicycle has nothing. So that's nice. We see that we're using wheel count, but we didn't really, you can see that we don't actually have anything up here. So that means we're probably getting it from vehicle. So we see wheel count and power source. We didn't declare them inside of this class, but since we're extending vehicle, we can be pretty sure that they're somewhere up here. So for now, we'll just move on. This is all, again, all this code is posted in Slack. So if you're just like, oh, I don't remember doing this, totally cool. It's in Slack, all good. So it's a good car. Car doesn't seem to have anything either, declared, I mean. Clearly we're assigning things. A car is extending combustion powered vehicle, so, or combustion powered thing. So it's just this, we can figure that anything is coming from either combustion powered thing or maybe further above. And then let's look at truck. What does truck have? Bed capacity in gallons. That is how trucks work. Say bed cap. Good enough. So now let's take a gander at combustion powered thing, see what's happening in there. Also, I was a monster, sorry. See, airplane extends combustion powered thing. So that means we are going to draw a line from airplane to combustion powered thing. This is typically called UML diagramming. There are a million conventions for this. It does matter in some regard to where like how you draw this out, but think of UML mostly as a way to help you understand what's going on in the code. Doesn't really matter if like you don't have something perfect. In fact, what we're doing right here is not proper UML, but they're just all that matters is just that we're diagramming this. So airplane extends combustion powered thing. So we draw a line. Let's take a look at bicycle. Bicycle only extends vehicles, so we can be pretty dang sure that, well, let's do this. There we go. It's good. Looks good. So now let's check out car, extends combustion powered thing. Then take a gander at truck. That's the only one at this level that we haven't looked at. Well, truck doesn't really seem to extend anything. So what's happening? Nothing. Nothing's happening with truck. We're just going to leave it for now. Then now let's look at combustion powered thing. That extends vehicle. So there we go. So now anything, well, anything that extends from vehicle is going to get what's inside a vehicle. Anything that extends combustion powered thing is going to get combustion powered thing. So let's look at what's in combustion powered thing. We have radio channel and AC temp. Radio channel, close enough. AC temp, close enough. Is that right? Oh, that was right, perfect. Now, let's look at vehicle. Wheel count, power source. So wheel count, power source. Cool. So where we left off, well, more or less here. This is again a reminder. Whoops, you're not supposed to see that. That's for today's lesson. Get out of here. Yeah. All right, so we've got a class vehicle. And think of inheritances that you're abstracting things more and more. Sure, we call something a vehicle, but like, is there a thing called like vehicle? Like you don't say I'm going to go out and get in my vehicle. A vehicle is any sort of genre, I guess you could say, of things. So we're just abstracting it further. Vehicles can be bikes, they can be scooters, they can be cars, they can be airplanes, they can be trains, planes, automobiles, you know, all sorts. But so it's just, you want to think of like ways to abstract things more and more. So we have a vehicle, and like we just decided that after declaring a car, an airplane, a truck, and a bicycle, we were like, oh, they're all vehicles. So they all have a wheel count and some power source. Cool. So then extracting those apart, looking at truck, airplane, and car, we saw, okay, well, truck, airplane, and car all have, they all have engines that are powered by combustion. So then we created combustion powered things. And combustion powered things have electricity because they have an alternator. And then those give power things that gives us air conditioning, well, gives us electricity. So we have a radio, and then AC temp. We're just assuming that all combustion powered things have air conditioning. It's not always true. My car's air conditioning is pretty busted at the moment, but luckily I'm not going outside very often. Anyway, so we have, and then from combustion powered thing, we are, both car and airplane are inheriting from it. What we didn't do on last Tuesday, almost said Friday, for whatever reason, my brain can't stop thinking it's Friday. I'll be sorely disappointed tomorrow. But so what we didn't do last week is extend, we didn't have truck extend combustion powered thing. So what happens, So on this now, here, let's just erase that line. As of now, truck is not extending combustion powered thing. What's going to happen? So if I create a constructor and I say truck, and then I want to say wheel count equals 4, the runtime is going to say, or Java is going to say like, yo, hey, hold on. There's no such thing as wheel count. Where do you think you're getting that from? And this, if you ever see this when you're coding, you should think like immediately like, oh, hold on, step back. Because if you immediately say like, talking is so hard. If you immediately just say, create, local variable wheel count, all right, that makes the error go.
Wheel count. Oh. Interesting. My screen just told me that my microphone changed. Can you all still hear me? I'm assuming, oh, my headphones entirely died on me. All right, cool. There we go. Well, hopefully this, okay, you can still hear me? Awesome, 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 awesome. All right, so we've got wheel count in here 4, but this is local scope. This isn't the same wheel count as up in vehicle, right? So if you ever see this red squiggly, and it's like, yo, you didn't do anything with that. That should be like a quick warning, like, oh, you know what? I didn't extend the thing that I want to inherit from. So we could extend from vehicle, but then we wouldn't get all the stuff from combustion powered things. So instead I'm going to extend extends combustion powered thing. And then that's going to give us access to all the variables, in combustion powered thing, all the variables in vehicle. Now, before we go any further, one thing I want to say is that when I say, I think we briefly touched on this last week, but I don't think that maybe I said it as well as I could have. Whenever I say that, like, okay, we extend from combustion powered thing extends from vehicle, it's not that every time I create a truck and every time I create an airplane, every time I create a car, they don't all share these things. They're just using these as definitions. So if I were to create, a car and an airplane, and why not? We'll do a bicycle too. And let's do this in main. Ooh, that's so green, so much code. Okay, if I say, so my car equals new car, bicycle, my bike is new bicycle, then truck, my truck equals new truck. Cars are boring. We're going to be done with cars here very shortly. Ooh. Ayo, I did not import truck. Great point. So, truck. Right there it says truck cannot be resolved to a type. So what's happening is we have our main file in a different package than we do our vehicles. So we have import vehicles .bicycle. Oh, just like that's interesting because we're clearly, you can see here, we're using car as well. If you ever get worried that something's wrong, check line numbers, because for a moment I was like, wow, something's really broken. Let's see how it says 1, 2, 5. That's Eclipse trying to help us and say like, hey, you've got a lot of imports. Don't worry about it. I'll take care of it. I'll smush them all for you. If you click this little plus button, it'll extend all of the imports and show like what we're actually importing. I like to be able to see everything that I'm importing. But yeah. So now we're importing vehicles.truck. So vehicles, the name of the package, then dot truck. So that's all fun and good, but remember how earlier I was like, I like to see everything that I'm importing, or 30 seconds ago? That's well and good, yes, I do, but also, do I really want to see all of these? Sometimes yes, sometimes no. And so what's nice is that at this point, we're importing pretty much everything in here. So for the things that we can import, all the public things that are in that package, I can just say import vehicles.star. And what that's going to do is take every single public-facing class inside of this package, vehicles, and it's going to let us use it. So for our sake, we should be able to use, or we'll be able to use pretty much everything, except we won't be able to see that a class combustion power thing exists, and we will see a class vehicle exists, but because we don't have constructors for them, their constructors are default and therefore protected, which means that they're safe inside the package. But you'll eventually get more and more comfortable with protected versus private versus public. For now, I'd say be as explicit as possible. Always type out public or private. Protected is just a little weird because it's just this. Protected is a little weird since it's very it's package specific, or like think of file folder specific. Anyway, getting back to it, because we have so little time, we never have enough time. Everyone should vote to make these classes longer. So that's always more fun. Everyone wants longer class. So in main, in main, we have car, bike, my bike, truck, my truck. So I create a new car. Call this my car. My car is going to have its own versions of wheel count, own versions of power source, gas, its own versions of radio channel, V81, and then its own version of AC temp. Let's say 72. So cool. So then, if we have a bike, in my bike, I will have my own version of wheel count. Or well, bike. All bikes have 2 wheels. Bicycle. Anyone take Latin? Super fun stuff, that. So, what does bicycle have? Wheel count, power source. That's it. Legs. Legs are a power source. And finally, for truck, because I'm feeling lazy and time is of the essence. So my truck. Trucks typically have 4 wheels, but not always. In fact, let's make this truck 6 wheels because it's a Super Duty. My cousin has one of those. It's pretty impressive. So 6 wheels. It's the back two wheels, don't worry about the bed. Power source is diesel. Diesel, D-I-E-S-E-L. That's how it's spelled. Radio channel. Whoa, I never listen to the radio anymore. I don't know if KC95 still exists, but it's a pretty cool channel, like old rock. And then the temperature, you know, if you're hauling stuff around, it's gonna get hot. So you wanna, let's make it like 62, so it's like crazy cold in the car. And then finally, so we've inherited all this stuff, but also truck has a bed capacity. And I'll say it's 500 gallons. That seems reasonable, probably. I don't know, maybe. Let's do 200 just to be safe. So even though it looks like we should all, like, from this drawing, you'd think that everything should be sharing, you know, wheel count, they should be sharing power source, or all the combustion power things should be sharing radio channel and AC temp. It's not so much that they're sharing actual variables, they're sharing definitions. So it's just saying like, hey, I have a truck. That truck's gonna be able to have a radio channel and AC temp, and it's gonna have a wheel count and power source. It won't be the same as bicycle, even though bicycle's inheriting from that. It's ultimately just, all you're doing is saying, hey, I want this to grab the same, those definitions, those variables, so that we can use it. So like bike can use vehicles variables, or truck can use combustion vehicle, or airplane can use combustion vehicle. But fun story, super extremely fun story. Suppose you wanted to, I don't know, write a function, right? A function that you could work for, you know, have it work for a car, airplane, truck, and bicycle. You could very easily write a specific function for car, one for airplane, one for truck, one for bicycle, which is fine, totally fine. You can overload functions all you want. However, I don't want to clear these drawings. Yeah, I should clear them. No? Okay. Fun story, you don't actually have to, why are you complaining? Not have a, hey, look at that. Oops, didn't change trucks constructed in public. See, there we go. But if we wanted to have a function that could take in all of those, all we have to do is just say, hey, this function is going to take in a vehicle. Any vehicle, doesn't matter. Then we're going to do something with that vehicle and print toString. So toString is just a variable that literally takes everything in your object and then converts it to a string so that you can see what's going on. But that right there is called polymorphisms. You're saying like, I don't care what it is, so long as it's either a vehicle or it inherits from vehicle. That's it, doesn't matter. Let it use the function. And that is polymorphism in a nutshell. Ridiculously long word for just saying like anything that, pretend that these are fancily drawn boxes. Oh my gosh, this is the worst. There we go. Anything that inherits from this gets to use this. So all, you know, we have car, truck, bike, they all inherit from vehicles. So we can treat them as vehicles. Makes sense. Well, at least, I'm sorry, I shouldn't say it makes sense. Verbally, it makes sense. If you say like, Good example is speed limit. There's not typically, say speed limits don't exist really for bicycles, so maybe that's a bad example, but ultimately the two-string works just fine. So long as you pass in anything that inherits from vehicle, it'll be treated as a vehicle, which is really cool. So that right there is last week. It's a 30-minute bit, but that was what we did last week. And so this week I want to talk about, you know, how it's not always the case that things you can draw these inheritance trees super easily. Like, so think of a good example. We're gonna keep, dang it. We're gonna keep plane, because planes are cool. My brother and dad are pilots. Did not follow the family business, because even though planes are cool, they're very scary. So we have, where's text? I'm gonna keep vehicle, oops, and I forgot combustion powered thing, CVT. There we go. So we got those, right? And don't really care about this guy, not really gonna care. Oh no, I still deleted the text. Plane. Bird. So birds are pretty cool. Move this to a fully white screen. So birds are cool, but let's create a, shoot, where did you go with the box? So let's create a flight. So plane, I'm gonna move this further down so it's easier to, come on. There we go. Oh, come on. So we've got a combustion powered thing that extends from vehicle, and then a plane that extends from combustion powered thing. Let's say we want both bird and plane to get the things in flight. And the things in flight are, you know, like, say, method of flight. There are lots of them, which is surprising. You wouldn't guess. So tragic story, very tragic story. In Java, and in fact, in most, almost, I'm going to say all, it's not all, but in most object-oriented programming languages, you can never, ever extend more than one thing. So we have a plane that is combustion powered, and it is a vehicle, but it also has this method of flight. We can't say plane extends combustion powered thing and extends method of flight, just, you know, because that's how the language exists, even though you should be able to do both. So the way that we get around that is, instead of saying method of flight is a class, or flight is a class, what we can do, oh, there's arrows, dang, oh well. What we can do is use a thing called an interface. And so an interface isn't, it's not so much a class per se as it is a kind of, I don't want to keep saying definition, because while it is a definition, it's not. So an interface is something to think of it as like a contract, where you're like, you do a thing called, you implement an interface, and in UML diagrams, it's always a dot, it's a dotted line. And Bird's also going to dotted line its way over. So you implement this interface, and what that does is that you're basically signing a contract saying like, hey, I know I'm writing this plane class. I'm going to implement that interface flight. But in doing so, you have to then promise, by promise, I mean, it's written this way so that your code will fail to compile if you don't do it. But you then are saying like, I promise I will write the function method of flight in any class that implements this. So then I will have to write a method of flight in bird. And I'll also have to write a method, a very special method of flight in plane. And you might be wondering like, okay, cool, then that's not really, I mean, it's not really inheritance, which it isn't. It's implementation. So what this does is that this allows for us to say like, hey, you know, it's a little bit more loose than inheritance. Inheritance is like, it's an is-a relationship. Like a plane is a combustion powered thing. It is a vehicle. Whereas plane isn't a flight. Bird isn't a flight. Birds can fly. Planes can fly. So think of it. It's hard to sort of abstract these things, right? Because you can code anything any which way, and like generally speaking, will be fine. But when you're designing these programs from scratch, it's always good to sort of think ahead and say like, how do we want to design this? It could be the case if you really, really wanted to where you could build your program to have, you know, flight be a class that both bird and vehicle inherit from, and then plane would eventually get the stuff because it would inherit a combustion powered thing, and then it would have everything. But not all combustion powered things can fly, and not all vehicles can fly. So you want to be a little wary of how you're doing this. So with all of this being said, though, we've got vehicle, combustion powered thing, plane, bird, and flight. How do we actually do this in code? That's the whole reason why we're here, right? So let's ditch take trip stuff. Let's create a new, right click on the source, go to new, package. Ooh, that's right in the way. Then I'm gonna write, I'm gonna write animal, the animal package. And then inside of there, I'm gonna say new class, bird. Bird's the word. So what do birds have? Feather color. I don't know. Yeah, sure. Birds have songs. I don't really know how we say that, but we'll do bird song. Why not? And then chirp volume. The birds that live by my house love to chirp extremely loudly at about 3 in the morning. They're so great. Should let my cat outside. That would mean you demolish those birds. So, got bird, got plane. What we need is Superman. So I don't know if that reference, whatever, stupid Superman joke. Anyway, so we've got all these things, but we don't have an interface. So you could wonder, like, where do we want to put it, right? And it's, can like this flight interface, should it be inside of animal? Should it be inside of vehicle? Should we create a brand new package just for that interface? We could. For now, I'm just going to put it in main package. So if you right-click main package, then naturally, see we have package, class, interface. What? Interface. Click on that. Then see we're in polymorphism source, main package. What is the name of our interface? Let's call it flight. Finish. So what does flight look like? So flight, so we see public interface flight. This looks just like the same structure as a class, right? We see our classes all say public class, and then whatever our class name is, flight, or this interface is the exact same thing as a class, the structure at least, at this level. It's just instead of saying class, we say interface. Now, here's where interfaces and classes differ just wildly, right? So interfaces, or so classes, you can declare variables, you can declare methods, and you can just implement them however you want. So you'd think, right? You're like, oh, well, interfaces are probably similar enough. You can do the same thing. I say string. I don't know. Flight stuff. Please fail. No, you're not going to fail. You're going to be really cool, aren't you? Yeah, just tell me. No. All right. Well, ugh. This will please error out for me. There we go. Okay. So why it wasn't throwing an error earlier, we'll see right now. But so if I say string flight stuff and then wait to declare it later, like everything's gonna blow up, because any single variable that you put inside of an interface is immediately a constant. It's a final. So what that means is no matter who implements method of flight, whatever you code right here, that string is going to, flight stuff will always and forever be whatever string you declare it. So if you hover over this, it's going to say the blank final field flight stuff may not have been initialized. That's the compiler just essentially saying like, hey, you've got an empty variable in here. That's a final variable. The final is a constant, which means you can't change it. So if I did say, I don't know, flight stuff, flying is neat, it's then going to fix our problem. But even doing this, Eclipse and Java, well, Java, it's really just the Java compiler, and also Eclipse not telling you. Eclipse should warn you, honestly, but they don't. This is deceptive, right? Because you say like, oh, cool, it says string flight stuff. I should be able to change that. Let's try to do that. So say airplane, then to actually implement got like a bunch of these zoom menus all right in the way of this. There we go. Nope, can't see that, I don't think. But so, okay, so we've got public class airplane, extends combustion powered thing. Then I can say, and it implements, if I could spell implements, geez. So it extends combustion powered thing and it implements, does it implement? Flight. So now, this is not helping, come on, get out of here, guy. There we go. Back. So it implements flight. If you hover over flight, I don't know why I moved it. Like I should have moved this all over the place. So it says 3 quick fixes. Let's move. You know what? We figured this out. Well, yes. Save that. I don't want to save it. Let's just clear everything. I really wish that you could like just wipe it, but then bring it back. But we all, I think, got the general idea. So we implement flight, hover over it. We can either create our own interface flight, or import flight from main package. Well, we declared flight instead of main package, so let's click that, import main package.flight. Awesome. Super cool. So now if I suppose in our airplane constructor, could then say, you know, so inside of flight, we had flight stuff. So in our airplane constructor, I could print out flight stuff. I can interact with it just fine, just as if I was inheriting from something else. However, if I were to say flight stuff equals new thing as a string, it's going to get angry, because even though we never, ever said, we never wrote final to show that this is a constant, it's doing that behind the scenes. And that's why I'm a little irritated that Eclipse doesn't actually show that, because it's really easy to forget sometimes. So when you go to hover over this now, it's going to say, hey, the field final, or the final field flight stuff cannot be assigned. That's really just them saying, Eclipse finally saying like, hey, sorry, can't do that. So whenever you find yourself writing an interface and you have any sort of variable in here, just do yourself a favor and just write final in front of it. If not, just for a reminder for yourself. That's it. But fun story. The whole point of interfaces isn't just so that we can have a bunch of shared constants. It's not the most helpful thing in the world. It's not unhelpful, but what makes interfaces so powerful is that sort of contract that both bird and airplane are going to have to sign and say, like, we promise we'll do it. And then that's done with a method, but it's not quite the same method as before. So let's just say, well, let's make this return. Method of flight. So when we've typically written methods, you always, you say like what the return type is, what it is, if it has any parameters, and whether that's public or private. Doesn't really matter. But so even if I said, return whatever, because I think it's complaining because I'm not returning a string. If you hover over this, interfaces are curiously not, they don't allow for you to actually write your method. And this is why they're so powerful, right? It'll make sense here in a minute. So say string method of flight. It's not that I want to have the method of flight described here, because remember, we have airplane and bird implementing this. Airplanes and birds don't fly the same way at all. So what we're going to do is just say method of flight. So we have that string method of flight, and this is again extremely deceptive, right? So it's not so much that we're just declaring a method and leaving it. Behind the scenes, this is called an abstract method. So you're going to want to put this keyword in front of it called abstract. All that does, all this means, is that in airplane, when I implement flight, it's going to immediately start throwing an error. If you hover over that error, it's going to say, oh, hey, the type airplane must implement the inherited abstract method flight.method of flight. What does that mean? It means we're implementing this here interface. And by doing so, we're promising, we're saying, hey, that function method of flight, or method, that method of flight, I've chosen a better word for that. It's a flight style. There we go. That method called flight style wasn't implemented in flight, or wasn't done in the actual interface flight, because the whole point of using an interface is to say, like, oh, it's a little kind of more wishy-washy. You do the work, like, so it'll make more sense for you. So for playing, right, flight style. And so it's called AO. Return statement. There we go. Return radar, don't do that. Return jet engines. So that's our flight style. So all you want to do is just say, like, hey, I promise I'm going to write that function. That's all an interface is saying. However, suppose you did it from this angle and said add unimplemented methods. Click that. What's going to happen is you're going to see this here override thing right there. If you remember from last week, all the override means, all it means is that you are writing a function, you are writing a method that has the same exact functions or the same exact signature. So string, it's returning a string called flight style as something that you're either inheriting from or implementing. So humorously enough, flight style, who would have thought, control click in there, it's the same exact thing as flight style. So we did that for airplane. Let's now return flies with a jet engine and wings. Rockets fly with jet engines. Wouldn't really call those planes. Now, so for bird, we're going to do the same thing. Bird is going to implement what? It's going to implement flight. Then it's going to complain because we didn't actually import it. So if we just hover over it, import flight, or could do import main package dot flight. Doesn't matter if you type it out or you press the button. The one thing I should say is that clicking what Eclipse thinks it's helping you with is not always the correct answer. So Eclipse is smart, but it's not the smartest thing on the planet. So sometimes it's good just to type things out for practice. So then, how is it 5:30? Okay, so then inside of bird, we can then say, we can create our own method of flight and say, not method of flight style, return flies with the flap of a wing. The flap of a feathered wing. Bugs fly with wings. They don't flap them like birds do. Those are webbed wings. Those are pretty cool. Bugs are great. Anyway, and then finally, might as well, create a constructor. Feather color equals Blue jays are neat, I guess. Song equals, I don't know. I don't know why I chose this. Chirpy things. Then chirp volume equals, what's the chirp volume of a bluebird? Pretty loud. Monsters. Then also, we should make sure that we spell this correctly. So there, we've got chirp volume. We've got a bird with a flight style. It's implementing flight. Notice we didn't write override. We can. Oops, but we should spell it with a capital O. All override is doing is just making sure that this method exists in something that you're inheriting from or implementing from to throw a compiler error. This is the safer way to do things. But those decorators can be a little scary, I think. So all it is just, ensuring that you did your due diligence. So now, let's get rid of all this stuff. Let's create airplane. Let's create an airplane. Oh, that's goofy. That's stupid. Forget how to spell Cessna. That's fine. Cool. Why is it complaining about airplane? Why do you think? Well, let's hover over it first. This constructor airplane is not visible. When we made our airplane constructor, we didn't actually set it to public. So anything inside of the vehicle's package can see the airplane constructor. We can make new airplanes in any of these other files if we wanted to. However, if we want to use it outside the package, we have to make it public. So let's do that. Make this airplane public. Domains in there. We got a Cessna. And then let's create a bird. Blur bird. Good enough. Let's do bird. Great. We did it. Why are you complaining? Because we didn't import bird. Let's see, it tells us the package animal. Let's just do that real quick. Importing bird animal. Then what's it doing? Should we change the visibility of bird to public? Heck yeah, because we need to. We should. So, got a Cessna and a bird. Now, I could write just that different line. Flight for airplane is. Then I can say Cessna dot flight style. So there's dot flight style. Notice it returns a string. That's the function that we made, right? Returns a string, flight style, awesome. Semicolon. Then, are you not going to double the line for me? I thought I had that. Oh, dang. I really thought I had a shortcut to double the line. So I'm just going to copy paste because I'm feeling crazy. Copy pasting is bad. We're going to fix this here in a minute. Instead of saying Cessna.flight style, we'll say blurbird.flight style. Hit play. Blam. So we've got method of flight is flies with jet engine and wings for airplane, and then for bird, it flies with the flap of a feathered wing. Super cool. But the coolest thing, one of the coolest things, so I should say, before we go any further, that was a lot. This is a fair amount of stuff. I teach Java to college students, and this gets them really hard. And I don't expect you to fully grasp this right now. Like, there's no need to. Like, this all requires practice. This all requires, just doing it over and over and over again, and you'll get used to it. I didn't even fully understand interfaces until much later. I failed my first job interview because of that. They asked me to do an interface coding bit, and I bombed it terribly. So if this doesn't make complete sense, don't worry. This is just, again, like a way to introduce you so that when you do see, if you're writing some code and then you do see that when you go to implement something or extend something from a robotics library, if it says that you don't have an implemented method, that'll be because you have an abstract method that you're using. So that's all you really need to know. But when you do want to end up writing your own interfaces, this is good reference. So with all of that being said, are there any interface questions at the moment? That was, yeah, a ton of stuff to go through. Such silence. Oh. Well, if you do have any questions, post them in the chat, and we'll definitely take time to get to them. But now for the thing that I think is the most, one of the coolest things about interfaces is that they also allow for polymorphism. So we had this, take a trip where we can pass in anything that extends from vehicle, right? Anything at all. We can also do the same thing with interfaces, which is wild. So static void, I'm gonna say print flight method. And then I'm going to use the actual interface. I'm going to say that interface name, even though interfaces can't be made, like they can't be instantiated, which is also, I'm so sorry, I forgot to mention, you can't instantiate an interface. I can't say flight some flying thing equals new flight. This doesn't work at all because if you hover over this, it'll just tell you you cannot instantiate the type flight. You cannot instantiate an interface. You can't make a new interface. You can't think of it like you can't create a physical representation of a definition. Like a definition is just really like words. Ooh, don't delete all that. It's just, or an interface is really just a contract. So you can't create a new one. It just is there for other things to adhere to. So going back up here though, we're saying, and this is the part that's like really like crazy and mind-blowing. We're saying like, hey, flight, some flying thing. I'm gonna say some flying thing dot, oops, not dot. Well, I want to do that. I wanted system dot out dot print line method of flight is, and I could say some flying thing dot flight style, which is insane. So instead of having to type this out a bunch, let's just say print flight method for Cessna. Print flight method for Bluebird. Beautiful. Where's the play button? Then we get the same thing that we did before. But what we didn't have, or what we did have before, was saying like one said airplane, one said Bluebird, and because some flying thing doesn't have like airplane or Bluebird, or there's no name in there, and even if there was a string in there, it would be final. What we can just as easily do is say, type, and then So the method of flight for type is, so now I can say type airplane, type bird. There are other ways to do this. Of course, there are a million ways to do anything, but I personally think that just making things easy by passing strings and passing stuff like that makes a lot more sense than doing a little bit more, you could say advanced, but more difficult looking things. So let's play. The method of flight for the airplane is flies the jet engine and wings. And then the method of flight for a bird is it flies the feathered wings. So all of that, I can't believe we only have 20 minutes yet left. This is hefty material. Any questions? I think like the craziest thing is this right here. And the reason I wanted to show this to you isn't necessarily because we're like, hey, look what you can do. Isn't that neat? Which it is neat. It is cool. But if you go to list, I wish that I had this image pulled up immediately. Come on, where are you? This is what I wanted. So there's a thing that we're going to try, hopefully get to next week called a collection. And it's just a fancy, big class-based kind of array. But, but from that, there are different things. There's sets, where if you've taken some math classes, a set is just a list that has only all the elements in a set are unique. So if you have a set of numbers, you can't have 1, 1, 2, 3. You can only have 1, 2, and 3. There are only unique things. And then for a list, there are things called Arraylists, which is really just a fancy array. And there's a queue, which is essentially just a line. So it's a first in, first out. So like think of a queue as literally you going to the grocery store and buying things. And when you put an element inside of a queue, whenever you try and take something out, you have to remove something from the very front of the queue. These are just sort of data structures that other people have coded for us to use whenever we need to. But what's cool about all of these is that they all implement the interface collection. They're all from the collection interface. And then, so the interface set implements the collection interface. The interface list implements the collection interface. The interface queue implements the collection interface. All of these interfaces all stem from collections. So if you have a hash set, which is a fancy key value pairing for words, we'll get to that next week. If you have a hash set, if you have an array list, if you have a priority queue, any of these things, you can write a single function that uses the collection interface, just like how we did with the flight interface. So that way you won't find yourself writing a special method for just collections. You won't find yourself writing a special method for priority queues. You can write a single method to use the collection level element, or the collection level methods, like dot length or dot push, dot pop, those things, and then you can go from there, which is extremely powerful because that saves you time, that saves you energy and thought, because you can just say like, oh, I have these different kinds of things, but they all ultimately use the same thing that they're implementing. Or you can think of it as just a fancy way of inheritance. Think of it however, whatever is easiest for you to think about, that's the way to think about it. That way you can just ultimately save time. Hopefully that wasn't too crazy of a tangent, because that was a little bit of an intro to what the plan is for next week. But until then, I always try to get to doing an exercise, and there's so much stuff to cover. So we're not going to do an exercise today. You know, we haven't done a single in-class exercise since like the first 2 weeks. So sorry, just to hear me drone for a while. So now, interfaces, collections, all that stuff, that's going on the back burner. What we're going to do now is talk about 20 minutes, a little under 20 minutes. We're going to create a new project, new Java project called file stuffs. Don't create this brand new thing. So file stuffs, what's in here? So I'm a liar. I called it file stuffs. It should have been called exception handling and file stuffs, but so first, we create a package. Always call it. I know it's a discouraged package name. We're going to call main package, where we're going to keep our main function, or sorry, our main class that will have our main function in it. So class main. This is something I like to do. You can name your main class anything. And then inside of our main class, we write public static void main string brackets args. There we go. We've got our main function. Huzzah. So this is fun, right? So we've got, there's so much to cover. Fingers crossed we get to collections next week. So up to now, if anything were to ever go wrong in your code, it's going to blow up. So if I say int my number equals, 1 divided by, or we'll say 4 divided by 2. This is dot line. Whoa, neat. My number is, very exciting. How excited are you to see basic math? Whoa, cool. But let's say I wasn't paying attention. I wrote 4 divided by 0. So as far as the compiler is concerned, as far as anything code-wise is concerned, it's like, heck yeah, totally makes sense. Got an integer divided by another integer, that's all that matters. No big deal. When you run the code, you're gonna get a major exception. Divided by 0. You can't divide by 0. It's just not how that works. Whenever y'all take calculus, you'll learn about limits and how these things all work. But basically, you just can't divide by 0. It's not feasible. So suppose this accidentally happens in a program that you yourself were creating to take in some data from a file, say from a user, or anything. And in fact, let's do that. You guessed it right now. What? So we are going to, dang, get out of here, code. Pull my notes up. We are going to import something called the scanner. So we're going to say import java.util.scanner. So what is a scanner? A scanner is something that takes in data from a given input. So I'm just going to delete all that. So I'm going to say scanner user input equals new scanner. And if I then just do this, it should complain. Fingers crossed. Thank you. I wasn't sure if it was. So if you hover over this, it's going to say the constructor scanner is undefined because not everything has a default constructor. And this is a good reason as to why. So scanner is literally, it's a class written so that you can tell it where you want to read information from. So if you look through all of these, there's files, there's input streams, there's paths, there's all sorts of different things. What we want to do is we're going to say system.in. What is that going to do? So system.in is literally how we're going to interact with our program through this terminal, this console down here. So now if I say system.out.println, tell me your name. I guess tell me your name is like an imperative, it's not a question. Then I say string name, and just declare it. I guess we could have declared a string name up here if we wanted to. Then I can say name equals user input, then dot. So there's all these different methods in there for us to use. What we want to do is do user input dot next. So let me do that again. User input dot. So we look at next. There's so many different kinds of next. There's next. There's next with a pattern. There's next with a string that for a pattern that we can put in. There's next line. There's all sorts of things. There's next byte, next big integer, next int, next float, next decimal, next long. You generally speaking ought to be aware of what your user is going to be putting in, or at the very least of what you're going to be reading. For user input, it's a little difficult because humans are really bad at following directions. Computers are generally really great at following directions, so we can be a little more lax with that. So nonetheless, we should know these things. So let's just do next for now. Then say system.out.println hello name. Back to the hello world of week 1, right? So press play. Tell me your name. Well, clearly we didn't see hello name printed yet. So what's happening is this right here, this name user input dot next is waiting. It's waiting for user input. The program itself is just spinning, just saying like, hey, give me something, give me anything. So let's say Matt. I enter that, hello Matt. So this way we get to interact with our machine and our machine gets to interact with us in a very back and forth manner. However, let's try this again. Tell me your name, 123. Hello, 123. Not my name, close enough. Because we're passing everything in as a string, it doesn't really matter what we put in there. Let's try doing a little bit more. So let's do some math. Enter a numerator. Make that a print. Whoops. I'm lazy, I'm just gonna copy this. Enter a denominator. Then, oops. Value is, or the decimal value is, and we're going to print out some decimal value. So now, let's do these things. So let's say int heck double. No, these are rational numbers. So let's do int. Int numerator equals not scanning user input dot next int. So we have an integer. Int denominator. There you go. User input dot next int. Then say int division equals, you know, numerator divided by denominator. There we go. So this is easier to read. There we go. Let's say division. Generally speaking, tell me your name. Let's do some math. Enter a numerator. 23. Enter a denominator. I don't know. Exception is thrown. Why is an exception thrown? I was expecting an integer. Let's try this again. That, 1t, numerator 2, denominator 0, exception thrown, divided by 0. And there's going to come a point where I'm going to get really tired of this, right? Where it's just like, okay, fine, like I don't, like, it's not cool that like that data is being entered. What if there was a way to catch that and then just kind of move on? What if I really wanted to see, you know, this string, look at me. It's gonna try and type out the tragedy of Darth Plagueis the Wise, but that's a lot. That's long. So we've got this bottom string that we really want to get to. We really want to see this string look at me, regardless of what happens here. It doesn't matter what happens here. All I want to see is this. I want to get through this code, but if there's an error there, so be it. So how do we do that? We do that with a thing called error handling. So error handling, you write 2 blocks of code, sometimes 3. The first block is a try. So let's do that. We'll say try. Oops. Usually you wrap it around the stuff that might throw an error. So let's say try, and the stuff that might throw an error is the user input. Put all of that inside of this try. So if any of this fails, that's going to immediately get caught by this catch. The catch, I'm just going to call this exception ex. Oof. This is the different line. Bad news. Exception happened. And then typically you can say ex dot, or you can print, oops, dot, all sorts of things. You can print get message, you can print to string, you can print all sorts of different things. I want to print out, or I want to say ex dot print stack trace. So print stack trace is essentially, it's a function inside of exception. If you control click into it, there's a ton of stuff in here. You can do that with any provided Java stuff. So if we search for print stack trace, come on, are you serious? Where are you? Oh, it's extended throwable. Print stack trace is in here. Right, print stack trace. Oh boy, well, whatever. We don't need to dig through this code. Print stack trace essentially is just going to print through some like crazy stuff. So let's just go back. So now let's try this again. Let's say that 2. You know what? Let's just do 1. Cool. Decimal values 2. Oops. Great. Awesome. We got all the way down here. We didn't even see this exception because we didn't have anything to accept. But let's try this again, and let's purposefully break our program. Say that, do some math. 1 divided by 0. Bad news. Exception happens. Divide by 0. Then notice this bit right here. This string, look at me, is happening in the middle of these things. And that's a little weird, right? So, oh, we only have a few minutes. Oh, man, time flies. So what happens is this right here, this print stack trace, there are, fun story, there are multiple ways that things print to the terminal. These things, so system.out.println prints to this standard buffer, where basically it's a queue to the output of the program is saying like, hey, when you get the time, print this, do that. This print stack trace here is an error. So, and then what that does is that says, I don't care what's coming next, print this line immediately. And then if something does come next, such as this string look at me, such as life, it'll print the next thing. And it'll just keep printing to the console regardless of who's in line, whatever. So if you ever see stuff that's bisected like that, don't worry about it. Just know that a lot of times these error messages just disregard the buffer entirely and say like, you know what, don't care who's in line, it's my turn. They're very rude, but for good reason, because they need you to see what's going on. So, oops, let's just kind of get rid of that. So now we've got all this, but fun story, and you know, today we're just going to end in a quick note. You can catch more than one thing. Remember how earlier, so we have this divide by 0, and then where the heck? Then we can also have, oh crud. Ah, come on. So this again. We had divide by 0, and then we had input mismatch exception. So you can catch not just any exception, and this is another form of polymorphism, right? So exception, there are all these different kinds of exceptions. And if you at the very beginning just say catch exception, literally any exception whatsoever, so long as it inherits from exception, gets caught, it'll just go here. But what if this was like my last case scenario, right? What if I wanted to catch specifically an input mismatch exception? And then also, of course, I want to import it. And I can say, so system.println, you entered garbage info. Do better. Or, you know, I wanted to have, so let's try this out. Let's now say, tell me your name, Matt. Hey, enter a number. You entered garbage info, do better, because clearly not a number. Or, let's try that again. 1, 0, divide by 0, arithmetic exception. So let's, arithmetic exception being this thing right here. So let's do that, let's catch that. This is arithmetic exception, bad math. Then say system.out.println. You entered bad math. And let's do bad math dot get message. Try this again. Tell me your name, math 1, 0. You entered bad math, divide by 0. Look at me. So what's cool is, you know, you can keep doing that, and also we'll be done here in a second. Sorry. So you can then start, catching individual specific things and then dealing with them individually. And also, you're printing out a message saying like, you're bad at math isn't always the most exciting thing in the world, but you can do a lot of stuff in here. The one thing that you can't do is see how we say int numerator, we're declaring numerator inside of this try. Because it's declared inside of these curly braces, I can't access numerator out here because we're in a completely new set of curly braces. However, you could do is declare them outside of the try-catch block and then access them anywhere. So say int numerator, denominator, and division. And all this is doing, I don't know if we mentioned this, sorry if I didn't. All I'm doing here is saying like, I've got 3 integers, or 3 variables, they all are of type integer. I'm not going to declare them yet, but just going to, here we go. Just comma separated. All we're just saying that those are going to exist and do some work at some point. So then you can now access them here and say like, and then say like if this is not the one I want to do. This is input mismatch. Say, and it's also not always the case that your arithmetic exception is going to be divide by 0. But so let's just say, so if denominator if denominator g's equals 0, we say, are you complaining? Oh, there we go. Zero. That's against math rules. Here's numerator divided by 1. Then you say, why are you complaining? Okay, yeah, it's complaining because it wasn't necessarily initialized. There we go. It tells you 0, -1. So then we're going to say, and oh boy, fine, jeez. Turns out you need to initialize things. Very good habit to get into. So you have numerator divided by 1 or -1, or so now we're going to say that as well. Now finally I'm going to say line numerator divided by 1 equals, and we're just going to do numerator divided by 1. So finally, tell me your name, numerator 23, denominator 0. Then to say, you can't divide by 0. That's against the rules. Here's 23 divided by 1. So then clearly 23 divided by 1 is 23, but you get the gist of it, right? So there's a lot you can do, a ton of stuff you can do with try catches. Basically, you're writing your program so that it won't crash based on a random thing, like say an array out of bounds, or bad math, or any number of things. So this is basically, you are writing your code to be a little bit more elegant so that it can fail gracefully and then keep on going, because when your code crashes, it just stops. this lets you say like, okay, shoot, we crashed. We'll log it, but like, let's keep going. Let's keep doing work. So there we go. Next week, we didn't get to say reading from and saving to files, but that's next week. And then we're also going to talk about some lists and collections and cool things like that, so that you no longer have to keep just defining your own arrays. You can let the code do it for you. Are there any questions at all? Okay. Again, if you do have questions, post in Slack, send me a message in Slack, or just post in the channel. This will all be pushed up. I will post like a little bit of an exercise later tonight. Then we'll go over it next week. And then from there, yeah, if you have questions, let me know. Oh, also additionally, there will be office hours on Thursday. If anyone's interested, please message either me or George or Ram or whomever, or just post in the channel saying like, hey, I will be at office hours. They'll be on Thursday at 4 p.m. And that's it. So with that, thanks for tuning in, and y'all have a great Tuesday. And I'll see you, if not Thursday, then next week. And from there, the Java Masters. It'll be awesome. I'm excited about it. But all right, so with that, I'm gonna stop recording, and yeah, see y'all soon.